So very good morning to one and all, to the participants as well as the speaker for the today. So we have Mr. Vasant Kumar, Assistant Manager VI Solutions. So sir already participants kindly switch off your videos. Thank you. So we have Mr. Vasant Kumar V, so Assistant Manager VI Solutions. So sir has already handled the lab sessions on the day one. So hands-on lab view and virtual instrumentation. So his key interest areas are embedded systems, automation, digital image processing, sensors, data acquisition, signal conditioning, and wireless network. So today he is going to talk about the implementation of Industry 4.0 and its adoption in various sectors with some case studies. I welcome you, sir, for the session. Vasant,
Thank you
sir.
so much, madam. Thank you so much.
Yes, you can start the session, sir.
Thank you, ma'am. So before starting, I'll just share my video to you all. Just give me a confirmation whether you people are able to see it. Is my screen visible? I'm just trying to show my
Yes, sir.
presentation.
Yes,
Okay, madam. Thank you. So
yes,
first of all, it's my pleasure to be part again. So that today it's going to be a slightly advanced concept compared to the previous session. Previous session, what I did was on the first day, I was trying to show you people all about how basic the programming tool of National Instruments LabVIEW works. And there I was just trying to show some simple examples to you. I was even trying to show you how uh, industries prefer, what are the reasons why industries start preferring embedded system. So where I was trying to show you, how the process are being used, and know how the task management actually happens, and what is the reason a real-time operating system or real-time embedded application came into picture. I was just telling you people about that. So today it's going to be a little the advanced concept of the same, where everything from embedded, we started evolving into automation, then from automation, semi-automation, fully automation, now artificial intelligence coming into picture. So in this process of development, see, everywhere there is a development, this, and ultimate goal of engineer is to do some development. So which makes the human race very comfortable, luxurious, and make it more efficient when it comes to production and other sectors. So ultimately today I'm going to talk to you all about the industrial revolution 4.0. So when I talk about revolution, it has changed over the period of time. Okay, it has changed over the period of time. So as 4.0, they should be 1.0, 2.0, 3.0, and now we are just moving into 4.0. See, frankly speaking, coming to industry 4.0, nobody have a clear picture or clear cut idea about what is the standard. Everyone know what is the expected result, or what is the expected production sector to look like, how is the engineering should look like. They have the idea about that, but clearly not everyone has the idea about what is the standard. The reason why we don't know what is the exact standard, the reason is we are in a very starting stage of this industrial revolution 4.0. So we are like hardly 5 to 6 years into this in full fledged. So we are trying out all the different methods, all the different possibilities. If there are multiple tools, we are all open to not try to test, do some R&D works. And even if you see in the recent times, most of the faculties, research teams, JRFs, they work more on these kind of activities. The reason, very simple reason is we are not sure about what is going to be the real standards. So we are trying everything, and later, after some days, after some years, right, after a few decades, we'll come to know that what can be the best solution for all these problems which are coming across. All right. So the vision of today's program is going to be some list of items, like starting from industrial revolution 4.0. What is 4.0? I'm going to talk to you all about the history of industrial revolution, how it started, and where we are now. And because of that, what are the changes industry has gone through. Okay, and there are some industries are forced to do some changes. I'll tell you what are they. Excuse me. Nowadays, if you see in in a production sector, there are some standards to be fulfilled to get some projects. See, genuinely, these industries run on some projects, main capital projects. So these kind of projects to undertake central government project, or to undertake a multi-billion project, you should have a certain criteria which you have to fulfill. So people are no slightly have to migrate from industrial 3.0 to 4.0. So what are they? I'm going to talk to you all about. We don't know, as I told you, we are not sure about the standard, about what kind of technique we can use, what kind of platform we are supposed to use. We are not sure about that, but ultimately at the end of the day we are supposed to have something which is falling under the category of and the umbrella of 4.0. Okay, so which I'll be discussing to you people, and then what is the role of AI and MLT and deep learning, how it plays a very important role. See, if you see in the recent time, you would have been noticing most of the research work, most of the application, even in the market, when you see, when you're buying a phone, let me say it, the camera also, they say AI camera. All right. So wherever you see there is a artificial intelligence, the hybrid car, you have, the driverless cars, all these things are coming into picture. What is the reason? What is the role here? So there should be a reason why this has been grooming parallelly, right? So I'll be talking to you all about that. And role of industrial IoT. See, I think most of you have some idea about this, because this is even more buzzing word. If many people didn't know, industrial revolution 4.0 is somewhere, also, touching the IoT concepts. So people started working on IoT concepts. Then they came to know, yes, it is somewhere related to industry 4.0, and they started, doing a lot of research on this. So people have some idea about this. I can't say no, not everyone knows, have some idea about this, but I'm going to relate it. My ultimate role here is relate you people know how this industrial IoT is connected to your 4.0. So there was a demonstration, like a couple of days before, one of my colleague was, Mr. Rajkumar, was showing a demonstration where he was trying to acquire some data on a DAC system using a DAC MX application, and he was trying to host it in the the cloud, right? So this is going to be more similar to that. I'm if time permits, I'm even planning to show you the vice versa, which means that he showed how to push the data into the cloud. It is also needed to retrieve it back from the cloud from a different computer. That's a very important reason. See, when the things are communicating in internet, okay, it is not only needed that you always have to push the data, you have to also collect the data. Based on the collected data, you have to control something. That is how a complete closed loop system of IoT comes into picture. That is where they are related to 4.0. Okay, so IR 4.0 or industry 4.0, I can say. Okay, so I'll be showing you that if time permits to you. It all depends on how much time I'll just get it. I'm planning this to be hardly 15 to 20 minutes of demo, not much, because already you people have seen know how to push the data into the cloud. I'll anyway do it because I need the data in the cloud. I don't have that particular access to that. What Mr. Rajkumar was demonstrating. I don't have the access to that cloud because he would have used his credential, his Gmail account, to do the data, push the data into the Firebase and get the data. But I don't have the data, so I'll simulate some information. I don't have a DAC card here with me, so I try to simulate some data and push the simulated data to the cloud and get it back. That's what I'm going to do. Okay. Then how national instrument in industry. This is where case studies will come into picture. So coming to national instrument in industrial automation of current industrial automation, which is nothing but industrial revolution 4.0 or any automation platform which falls under IR 4.0. I'll be talking to you all about that, right? So what will make future? That's a very important question because we are like in the starting stage, as I told you. Of industrial revolution 4.0. So you should also be foreseeing what is going to come up, or what are the items which we are going to live in, and very importantly, why this is very much needed. Out of all, why this is needed is this is a practical life. Okay, so practically this session or this seminar, whatever we are attending, being this is the last day, hope you came across a lot of technologies, a lot of different speakers who shared their views and they shared their experience on how these tools work, or what their knowledge on how these tools work. Ultimately, you should know what is the next stage you are supposed to do, right? Excuse me. So I'll be telling you about that. And moreover, you can share this information to your students because most of them should be faculties. Since this is a faculty development program, share this to your students so that encourage your students to start working on toolkits, to start working on technologies much more similar to that, which makes the future. So ultimately, we are in need of a lot of engineers since it's a as I told you, since it is a starting stage of this period of revolution. We don't have much experienced candidate anyway. Okay, there is no, and you can see that slowly, this IoT, machine learning, deep learning are into all sectors, not a particular sector. So you see medicine, it is there. You see military, you see defense, it is there. Okay, you see marine, it is there. You see chemicals, yeah, it is there. You see, civil engineering, it is there. So everywhere it is coming up. All right. But how many expertise people we have? It is very minimum, handful of expertise people, and even those expertise people, we are not sure if they are expertise. The reason is we don't know if they are using the right standards of Industrial Revolution 4.0. So that makes a vital gate open for most of the people. Okay, so freshers or experienced people who have some idea about these tools, people are badly needing it. Okay, so how NI is preparing to face the future. So I'm just going to tell you about what is the future and how NI is planning themselves to face the future. Now, usually, if you see these companies, any company you see National Instrument, one such company which works there. What is their role in this global engineering sector? They provide hardware which is useful for engineering application. Any application, it can be image processing, signal processing, data acquisition, data control, control system, IoT application. It can be any application, but the ultimate goal is to provide hardware and software related to this application. Now they are going to release some more products in the future also, right? So they keep on releasing some products which is needed for the people, but these people have a challenge that they should predict what is going to be the future, because only then on the right time when the product is needed they can launch one particular product. So on that case they have to foresee what is going to turn over, what is going to be the cutting edge technology, like 15 to 20 years down the line. Only then they'll be able to invest some quality resource, quality time, quality capital. They have to invest some amount also, right? So they'll be able to invest in a right path, right? So how they are preparing themselves, because most of this is going to be related to all the other companies also, which will overall collectively will turn into the next generation or next future changes, whatever we people will come across. All right, so these are the few things I'm going to cover today. On this, I'll just classify these items into few agendas. So first agenda is going to be section number 1, where I'm going to talk to you all about industrial revolution 4.0. So in that case, I'll be talking to you all about the history, complete history, like 1.0, 2.0, 3.0. I'll be talking to you all about. Usually, you will come to know at the end of this section that excuse me, that 2.0 is a upgrade of 1.0, 3.0 is upgrade of 2.0, and 4.0 is a upgrade of 3.0. So in this case, you should also be somewhere thinking about what will be 5.0. You should start thinking about that also. That will also come into picture, because always there is a upgradation. That is what we people do. All right. Section number 2 is going to be talking to you all about how IoT works and how artificial intelligence are a part of 4.0, right? So where I'm going to show some demonstration. I have a demo for both from LabVIEW's perspective, because I'm from a background of LabVIEW where I have just worked on this tool for like nearly 8 to 10 years now. So I'm seeing the changes happening on this tool. I'm seeing the changes happening on this domain, and I have some idea like how it has groomed from where they started and where they have landed up and what they are planning to just move their next step to be. So I have some idea. So that's the reason I've just included these kind of demonstrations there, so that you people also cannot try it out, because I think you have LabVIEWs installed. I'm not sure whether you people have proper toolkits for artificial intelligence, because you need some extra toolkit to be installed. That is all right. But for IoT, you don't need any extra toolkits to be installed. So you can not start using with basic LabVIEW, because we'll be using HTTP protocol, because as I told you, that also will come into picture. So now we are showing a demonstration on HTTP protocol. Maybe that is not the right protocol to be used. The reason is HTTP protocol basically uses the normal network, whatever we people use. We use the Google Chrome, we use Mozilla Firefox. Usually we use this browsers, and we just use this search engines and communicate with everybody in this world, right? So you can't allow your things also to, because human beings communicate in this platform. All right. It's called www, which means that World Wide Web. We use this platform to communicate. You can't encourage your things also to get connected to these same platform. The reason is usually you have a restriction towards number of IP address in the www, World Wide Web you can connect to. Usually our IP address goes in this format: 255.255.255.250. This is a maximum amount of devices that can connect. Just think in India, or let me not talk about India. Let me say in one state, whatever may be the state. Let me say in one state, Karnataka, all these main institutions, let me talk about main top colleges, are supposed to be connected together in a single network and make sure they exchange the data among themselves. Let me say that is the scenario here. How many colleges we have, how many departments we have, how many students we have, how many equipments we have in every labs, right? So all these items are supposed to be connected to internet. How many IP address you want? Every device will have an IP address. Hope you know this, right? So every computer has IP address, every phone has IP address. Likewise, in the future you will see that all in production sector also. Okay, I'm talking about this college level. In production sector also, you'll have hundreds of machines. Every machine will have IP address. So you should find out a solution where you're already crowding the IP addresses. We human beings only are crowding it a lot. You can't allow these kind of non-living things to get connected on the same network and make it more crowded. So you will come up with a different idea. We have to come up with a different idea. We don't know what is the best idea right now, so we are using whatever is available in the market right now. So one thing which is available in the market now is the normal protocol, like normal HTTP protocol, TCP protocol, what we really have. There are much more upcoming things like under research. They are people are requesting everyone to start using IoT in IPv6. Okay, so not to use IPv4. We people start, we people basically communicate through IPv4. Okay, so fourth version. Okay, people are recommending to use IPv6. And what are the communication protocols which follow? There are different set of communication protocols that follow under IPv6. One such example is LoRaWAN. Okay, so LoRaWAN, WAN 16, and Sigma 6. There are some more technologies, or some more communication mode, like however we use the Bluetooth, however we use Wi-Fi. There are much more communication protocol also, which will come into picture in the future. Right now they are all in a research level, not into proper shape. That's why they are not into proper market. Okay, once they are into proper shape, you will start using them in properly. All right. And last is going to be about how NI industries are being using this Industrial Revolution 4.0. What are they trying to do? Ultimately, they're trying to do something, right? What is it they're trying to do? We'll be talking about different case studies. I have a few case studies to show you. I have some videos where they shared their experience, what they're doing, some demonstrations also in NI days. See, every year NI conducts, NI days. Every year they conduct NI week, where they try to call out all the industrial users of NI technology and come to show the demonstration, like how they have used them, how they use the tool, how they use the platform, what kind of solution they are making out, what are the troubles they are facing. If there is any community people that can help them, there'll be coming up to help them. So all these communicational forum meetings they usually arrange. On that NI weeks, NI days, whatever is being shared, I've just made some videos on that. I've just made some documentary videos on that, and I've just made it into a collection here to show you people. I'll be showing you that also, right? So this is the complete agenda for today. And jumping into section number 1, I'm going to talk to you all about very quickly about Industrial Revolution 4.0, where I'm just going to make more clear to you people, like where it started and where we are now, and what this basically is a smart factory. Ultimately, the byproduct of Industry 4.0, the byproduct of Industry 4.0 is going to be a smart factory. So, which means that once you start implementing this, protocol standards, the communication protocols, communication medium, network. Data transfers and everything, if you make it, ultimately at the end of the day you'll be ending up for a smart factory, ultimately in the production sector I'm talking about. Okay, so why smart factory is needed? It's a very important question. I'll be answering that at the end of this section. Okay, so very first we started with Industrial Revolution 1.0, where very first from human power we moved into mechanics. Okay, so we came up with mechanical models. These mechanical models are usually driven with steam power or water power. Okay, so like water turbine, moving the pistons based on the turbine. Or if you've seen olden movies, for example, if you've seen Titanic movie, you would have seen that in the basement there'll be like huge amount of people who just draw the coal and put it on a burning fire, so that that steam, the thermal steam what is being generated, they'll be using to move the turbines. That is the very first level of Industrial Revolution 1.0 came into picture. That is where our trains came into picture. The coal based trains came into picture. The salient feature of Industrial Revolution 1.0, it was marked at the end of 18th century. It gave the introduction to water and steam powered mechanical models. Okay, So what is the highlight of Industrial Revolution 1.0 was introduction to steam engine locomotives, the trains basically. Okay, steam engine rails was basically laid, and which helped us to transport items from one place to another. So the circulation, exports, imports were able to happen. Excuse me. So imports and exports were not happening till this was coming into picture in a very big level. Okay, this marked the imports and export to happen in a global level. Then came Industrial Revolution 2.0. This is more or less the same of Industrial Revolution 1.0, but people start doing this in a mass production. That's a very important part, where you can see that the same mechanical models, which is driven by thermal power or a steam power or by water power, you see that n number of people started working on that. Like there are n number of machines put over there. See, this is where stations came into picture. There's something called stations when it comes to production sector. Station is nothing but you have let me say you have 5 stations. One particular product, whatever is being designed, whatever being tested, or whatever is being basically manufactured, will go through every station one by one. Okay, it goes through the conveyor belts. That's where conveyor belts also came into picture. Electricity came into picture. In the production only, there was a mobility of duts. DUT is nothing but device under test or device under production usually. Okay, so the device under test started moving from one place to another, basically making a mobility coming into picture in the production sector itself. All right, if you have seen, one example, if you ask me, in the olden Charlie Chaplin movies, if you see the Industrial Revolution movies, they were coming up. There you see that the products usually move from one place to another. It undergoes multiple stages of production. All right. So salient feature of Industrial Revolution 2.0 was marked at the year of 19th century, and introduction to electricity, mass production, assembly line. Assembly line is nothing but where the conveyor belts will move the products from one place to another. Telegraph and mobility, as I told you. And this was basically first introduced in food production sector. Food production sector, where people in Europe had a very severe climate in the winter seasons. So what they do is they preserve their food, like meat. They usually eat more of meat. Okay, so they want to move this meat from one place to another. Okay, so in that case, when you preserve it, it undergoes a lot of process. Okay, so moving them from one place to another it's a huge challenge for them. That's where they started doing assembly lines. All right. Then what happened is the gentleman named Henry Ford felt this was a very good idea. Why can't we start using in automobile? He carried out this principle from food production sector to a automobile production sector. That's the first time a mass production happened in automobile or any manufacturing sector. What is the highlight of Industrial Revolution 2.0 was introduction to electric locomotive, like whatever we have right now, like your normal trains which is running over the cable. It draws a power from the cable which is lying over the top of the rails, or your basic metro rails, whatever is coming. Sometimes metro rails draw the power from the, in Chennai, if you see Chennai and Mumbai, if you see, it draws a power from the over lines. In Bangalore, if you see, there are like underground, below the train there are some railroads which is running, which carries the power, and your vehicle tries to draw the power from there. So depending upon the model they use, ultimately the highlight is nothing but electric locomotive. Okay, then came Industrial Revolution 3.0. This is where very first time people started avoiding people themselves, which means that all the production sector, everything they wanted to do with a robot. Okay, that's very important word, a robot. When I say a robot, it's something but it's computer which is driven through a software. Okay, ultimately a computer which is driven through a software. Till now, no one was using softwares. Okay, it was all a mechanical model. If not, it's powered by human beings, energy, or human beings effort. Okay, but very first time softwares came into picture at the Industrial Revolution 3.0. Okay, whatever you see here, I have a video, a complete video of this image, whatever you see, I'll just play that to you. Before that, I have some more things to show you. I'll show that and then come back to this and then show you how it is happening. So this is actually from BMW's production area. Okay, so the robot which they use is from a company called as KUKA, KUKA. Okay, KUKA robots are the one which is being used. I'll show a demonstration video also to you. I have that. Okay, so this was marked in the mid of 70. I mean, sorry, it was marked in the year of 1970s, mid of 20th century, and this is the first time when we gave introduction to partially automated. Very important, partial automated. Okay, I'll tell you what does that exactly mean. Partial. Many people doesn't know what is partial automated or semi automation. I'm going to tell you about that. So this gave introduction to partial automation using memory programmable controls and computers, which mean that you have memories like IC. Basically, what they're trying to say is some IC where you can deploy the program. It's a programmable control, right? And you can know do partial automation. Okay, coming back to know what is partial automation is, you can do a set of thing. You can program your machine to do something. Okay, you can ask it to do that particular set of tasks again and again, but it will not do anything beyond that. Okay, so it will not do anything beyond that. It will have a set of codes which is already lying inside them through IC or through some memory, whatever it is, and that particular set of codes will be repeated again and again. Okay, so what is a fully automated is nothing but it can also try to do something which is beyond its task, like trying to judge something, try to estimate something, try to predict something. These are things which come under a task. Task is doing some given set of data. Okay, so doing that is basically going to is called as a task. Something beyond the task will be called as semi automation, fully automation, sorry. So for example is you can see your washing machine. Okay, nowadays washing machine have two things: semi automated washing machine, fully automated washing machine. What is the differences? Semi automation, if you see it, you have to select everything. I think someone is unmuted. Can everyone be muted, please? Thank you. So in a semi-automated, you'll see that everything has to be selected by a human being, and you have to properly guide what is supposed to happen. Okay. Once you start it, once you give all the configuration, you start it, everything will be happening repeatedly. All that everything will happen repeatedly. Okay. You don't want any interference, which means that when once the process started till the end, you don't have to do anything. But when it comes to fully automated, where you can load everything pre in advance, for example, the soap, the detergent, the Dettol, whatever you want to use, you can just put the cloth. The machine will weigh how much cloth is being used, and it will understand how much dirt is there. It will know how much water to intake. It knows how much temperature to set. It knows how much spins to make. It knows what time it has to drain, what time it has to soak, what time it has to wash, what time it has to pre-wash. Everything it will know. Excuse me. So that is basically is a fully automation. So it knows. See, ultimately washing machine task is to wash the cloth, right? But it can do something beyond that also. Okay, where it can sense the information, where it reduces the task of a human being, basically comes into fully automation. Okay, so we were able to do this in every single task that entire production sector was completely automated. Okay, so then what is the highlight of Industrial Revolution 3.0 was robots that can perform program sequence without human intervention, which means that if they have a programmed set of codes, it will keep on repeating it. Okay, it will keep on repeating it without any human interventions. That is the highlight of 3.0. And coming to a very quick recap of what we saw, Industrial Revolution 1.0 was using steam and power. Industrial Revolution 2.0 was also using the same, but it was in a mass production. Electricity, mobility, steel, and power was being used. So it is highlight. I can say that it is a upgrade of 1.0, where it was from a single mission to an industry level of missions. Okay. Then came 3.0, where electronics and software came into picture. That's where very first time automation was coming into picture. We're trying to automate everything. There, what happened was we were trying to replace. If you see in the second picture for Industrial Revolution 2.0, there are many people sitting and working. People don't want that to happen. Rather, they want to use machines to do the task. Okay, that is where machines, robots, and programmed set of software based applications came into picture. Okay, now it's a time for 4.0. That's what we are trying to do. Already I said told you 3.0 is an upgrade of 2.0, 2.0 is an upgrade of 1.0, and obviously 4.0 is an upgrade of 3.0 only. So already we have machines, we already have robots, we already have softwares. It is already electronic driven. Okay, so what can we do it further? What can we do further to make it a better? Ultimately what we're trying to do is make something which is far better than what it was previously, right? So 4.0 is making 3.0 better, which means that the already existing robot has to be in a different level now. So ultimately, what we are trying to do in 4.0 is designing cyber physical system. That is what we are trying to do. Ultimately, in the very first slide, I showed you how to design a smart factory. I was telling you people about that, right? A smart factory is nothing but, if anyone asks the definition also, this will be the definition. A smart factory is a production unit, okay, a production unit, or any no unit which is related to production, because sometimes what happens, it is testing unit, you have packaging unit, right? Maybe it is not exactly working on the production, but it's something related to production usually. Okay, so a factory which is more related to production, where the machines used are cyber physical system. I repeat, the machines used will be cyber physical systems. Okay, so already we know what is physical system. Physical system is very simple, that the entity which doing some task. Very simply, a robot or a camera based system, because on the very first day when I was showing a demo, I don't know how many people were present that day and absent today, or how many were absent the day and present today. I don't know the list of people, but on the very first day also, I was trying to show you people how pencil sorting was happening, right? A soliton based pencil sorting video I showed. There was not much robots involved. Where what there was a sensor system, actuation system, where there was an arrow was blowing the pencils away from the line, and they were segregating. That was also a semi-automated system only, right? So any physical system need not be always robots. That's what I'm trying to say. Any physical system now will be you accessing the cyber. Cyber is nothing but your network. All right. So we already have missions. We are just going to make sure they are slightly better than what they were before, and we are going to add some cyber ability. Cyber ability is nothing but your uh, um, ultimately your internet. All right. Very quickly, I'll tell you about what is Industrial Revolution 4.0, what is Industry 4.0 also. So any industry which fall under this category will be called as Industry 4.0 or a smart factory. Very importantly, that is the actual terminology we have. Industry 4.0 is basically a standard. Industry 4.0 is a standard. Okay, any company or any factory or any production unit which falls under or which follows this criteria will be called as a smart factory. Okay, so as I said first, we are currently implementing the Industry 4.0, which means that we are not sure what is the proper thing. We are currently trying to do this. We are going to come up with a lot of changes. There are a lot of changes that have already happened in the previous also, we first came up with Windows based solution, because in India, if you see, most of the companies are not only companies, most of the personal individuals are only very commonly biased towards Windows, because we all use Windows application. Windows 7 we use, Windows XP. Before that, Windows XP we used. 8 was a flop, 8.1 was a flop. Still, we people had no computers. We bought them because trusting Windows. Then 10 came into picture. It was slightly better than most of the previous thing, but we preferred and we bought it. Now 11.0 is also coming. Windows 11 is also coming, but ultimately we will support Windows. That is how the mentality of Indians when it comes to Windows. Okay, we are not, basically we are not comfortable with Mac, and we are not comfortable with Linux. But when it comes to industry, many of the programmers also prefer this tool platform only. Basically, when it comes to computer based, there also we face a lot of issues. There the memory footprint was not that compatible. Either we are supposed to go for RTOS, real time OS, or we are forced to come into Linux. So now if you see, when it comes to IoT application where there is a standalone running, we'll see that there is no computer which is running on Windows will be supporting it. You'll always see, like you saw some demonstration like a DAC system, right, which runs on because he was showing a DAC card. Mr. Rajkumar was showing a DAC card which is connected to your computer. The computer is controlling it, which means that the Windows, or the processor from the Windows powered processor was controlling the DAC. Those kind of systems we don't use it in when it comes to smart factory, right? So where we will just start using either FPGA driven. We are fine with FPGA driven. Why FPGA driven is, FPGA driven will be falling under category called as SOM, system on modules, or system on chip also, depending upon what are the add-ons you have to the chip. Either we'll use that, or we'll go for RTOS, real-time operating system, or we have to go for, in worst case, the least we can go is Linux. Okay, Linux operating system will not be able to criteria wise Windows fail. The reason is the memory footprint what Windows use compared to other what I've mentioned was not perfectly good, and it is we need to put a hard disk which none of the the IoT device which basically wants. You don't want external hard disk. See, external hard disk you can use it in case if you're interested to log some surveillance data, right? But to run the OS, if you ask some big memory footprint, then it is not the right thing to happen. So at least for that reason, it was eliminated. Okay, so we are in a very starting stage. We are changing many things, and we are coming up with some new things. And what is this we are doing in this revolution is production system that already exist has computer technology, and now we are expanding them by a network connection, which means that that's what is called as cyber physical system. As I told, we already have some computer technologies, and what we are doing is we are expanding them by connecting them all to a network. Okay, so what this happens is what will be the end result of this is this enables the device to communicate and share the information among themselves to the other device, which means that if you have multiple, I was talking to you all about stations, right? N number of stations. These stations will start communicating with each other. These stations will start communicating with each other. This is the next step of the production automation, which means that this is going to be the fully automation system where you don't want anybody to assist the computers also. Okay, so this is what is basically called as a cyber physical system. You can ask me. See, I have just made few items in bold. You can see that this enables the device to communicate and share the information among themselves to the other device. So why is this needed? First of all, the very big question. This is what is basically is a cyber physical system. Using a cyber physical system is basically called as smart factory, and a smart factory is a criteria of industry 4.0. So ultimately what you are doing is connecting all together is basically nothing but industry 4.0 bottom line. So now the question, very big question is why to do it. Very simple question, why to do it, how it is going to make it better. I'll tell you very simple example. I'll tell you whatever I have. Let me say I'll take a very simple plywood, a wood piece, a wooden piece. Just notice everyone, this is little important. Just listen to this, try to understand what I'm trying to say, because I didn't make any videos or something related to this to make you people understand. I'm just trying to make you explain you and make you understand. I have a wooden piece. Okay, so my company is nothing but, my factory is nothing but producing a wooden piece which is going to be used for fence, the lawns and fencing we have, right? I'm just producing wooden piece for that on different height, different colors, different materials. You want plastic, I'll give wooden piece. I give you good piece, bad piece, materials, different types of materials I give you. Okay, now my job is to check if the wooden already manufactured wood is it's a good product. If it is a good product, I have to paint it. After painting it, I have to dry it. After drying it, I'll inspect whether it is in a proper condition to deliver. Very simple process. Paint it, dry it, check it can be whether it can be used for for selling the product. Okay, so now just think. Normally, how it can be done is I can have multiple machines. First machine will paint, second machine will dry it, third there is going to be one more machine which will just check or inspect whether it is in a right quality to be sold. Okay, very see three simple steps I have. Okay, there can be a number of steps. I'm just making it simple to make you people understand. Okay, because I'm not talking about slicing the wood. I'm not talking about making into the proper dimension. I'm not talking about those things. I'm just simply telling about this painting material. Okay, so here what happens is, very first before painting you have to check whether the product is a worth of paint, because after painting it, knowing that this is not a good product and I'm supposed to eliminate it or I'm supposed to reject this product, it's a waste of paint which I don't want it to happen. All right, so what I'm supposed to do is I'm supposed to add some sensors there, or I'm going to put some a camera or something to make me myself understand whether this product can be first put into a painting. So inspection comes in the before. Inspection is in the before stage. Then it comes to the actual station number one where painting happens. Then after finishing the painting, irrespective to which paint it is being using, irrespective to what material being used, what color is being used, what type of wood is being used, I'm going to put it into a oven where it is going to dry the paint. Okay, putting into the oven, drying the paint here is because I don't communicate these machines, right? So I don't know what wood piece is coming. I'm supposed to set a temperature timing in such a way that now it is common to all the wooden pieces, or I'm now restricting myself to use only one type of wood so that the settings are not changed now and then, because I can't change the settings now and then, right? Because if I'm supposed to do, there should be a one person standing there, analyze what type of wooden piece it is, and make the changes accordingly, which I don't want it to happen, right? So then coming to once again inspection system, usually a manual person sitting and testing or approving it. I wanted to do it through a machine. All right. So now you would have understood that there is an inspection system between happening between every station, right? Which is causing more time, which is causing more delay in the production, which is making the process very complex also, right? So now just imagine if all the products are going to be all the machines are going to communicate with each other. See, now before painting or while painting only, right, based on the movement of the brush, okay, based on the movement of the brush, like if it is a hard surface, how much vibration is happening, how much accelerometers data I'm getting, right? So what type of material I'm putting, everything, if I can just do some analysis, analogy, compute them based on some sensors data, it becomes more intelligence. That's where fully automation comes into picture, AI comes into picture. Okay, so if I can do all these things, okay, before without inspection system, I can understand that this is supposed to be a rejected piece, and if it is not a rejection piece, it's a normal piece, I'll paint it. That information of what paint I'm putting, how much thickness of painting I'm putting, what material of the wood it is, and all this information, if I can share it to the next mission, if I can share it to the next mission, if that mission also going to have a complete fully automation where it has some sensing system, it will understand this particular mission has to be put into this much temperature, this much period of time. It will also know that what should be sometimes what happens is the white color or pinkish, slight pinkish color should not be put into high amount of heat, because it will burn. That burning color will come. It will not be very dark. It will turn into bright, golden color, which is not good. It will change the color of the product. Okay. So understanding these things, right, we can adjust it. All right. And very importantly, out of all this thing, there's something called as mission condition monitoring, which means that, see, these are all going through process one after the other. All right. All these missions are taking the data one after the other. So when they take the data one after the other, what the problem we face is, if any one mission, it happens by some reason, what happens is one of the mission is broken down. There's a breakdown there. The entire process will stagnate at that point of time, right? Making your production to be stopped. And what you'll do is, once the machine is ready, you have to do OT. OT is nothing but no overtime to compensate all the shift which is lagging behind. Right? These kind of difficulties we usually face when a machine is breaking down. So what we do is we usually have a backup system every time. Okay, a backup system should be there, which means that for every product there is always a backup product, which is actually unnecessary capital cost. Now I'm going to put some system where there is always an internal health monitoring system for every mission, where every product ink or the battery or the ejector or piston, whatever is basically failing now and then, I'll be always monitoring the health. How will I monitor? I'll be just understand how much pressure it is undergoing, or how much temperature it is undergoing, what is the speed it is moving, what is the output parameters, measuring the flow, measuring the speed, everything. I'll be measuring it. I'll come to a conclusion that yes, there is going to be a breakdown, and because of this breakdown, I'm supposed to change this product. So before the breakdown happens, I have some time to take some measure actions before the breakdown actually happens and the entire production stops. Getting it? These systems are not only in production, in real time also. You see that in your phone, I don't know how many of you have seen this, your phone, you can always go check the battery's life. Battery's life is nothing but how much, sometimes it shows 76, 86, it says the health of the battery. Likewise, nowadays if you see the ACs, right, whatever you have AC, right, these ACs also come with battery life nowadays. the compressor, sorry, not battery, compressor health monitoring, it comes up. What it happens is it is internally, you don't have to connect it to Wi-Fi, what which is in your home. Let me say you're not having Wi-Fi, it means that that feature is now not working, not nothing like that. It has an internal system where it always checks the compressor's performance and understand, the health, the air quality, and it will always be pinging to the base station, the nearby base station. Base station is nowhere, nothing but the service center. Okay, so the service center will be sending the data, and even before it is going to lock down, even before this machine is going to lock down, you will get a message or you will get a call from the customer care saying that this particular product is going to break down. Okay, in the upcoming week we expect it to break down because we are monitoring the health status of this particular machine. It may break down. So you can let us know whenever you are available so that we can come and give you the service, right? Daikin, I don't know whether you people know it or not, that the company named Daikin is actually a AC manufacturers. They have these features available. I don't know if it is available in India or not, but they are already having this feature. Getting it? Yes. So these kind of reasons is why machines too should communicate to other machines, so that you can make sure that those machines can work better. All right. So how to build a cyber physical system? Coming to a conclusive thing, like making it very broadly classifying. What are the things needed to design a cyber physical system? The three things basically needed to design a cyber physical system. Number one is flexible automation and robotics, which we already have as the end of the industrial revolution 3.0. We already have a lot of robotics. All right, we already have a lot of robotics, uh, which are already doing all the automation in the production sector. So number one point is already existing. Okay. Number 2 point is connectivity is nothing but your IoT. Okay, depending upon how far you want to communicate, how uh, good the stream should be. There are different types of IoT. There's something called commercial IoT, industrial IoT, and personal IoT. Okay, and then based on what type of service you can provide, it is also called as active IoT or passive cloud. There are different types you have. Okay, then comes third point is intelligence. Intelligence is nothing but your artificial intelligence, making this collect some data. How you collect the data is through sensors. Sensors are the only way you can collect the data for machines. If you don't want sensor, then you have to go for camera, which is also one more type of sensor, but totally different from others, where it takes the imaging data, and from the imaging data, you have a lot of information comparatively, and you can do a lot of image processing related applications. Okay, so only two things we have is sensor and your basically your cameras are also called as image sensing devices. Okay, but they're also sensors only basically. Okay, you can either use sensors, normal sensors like analog digital sensors, or you can go for camera based acquisition, so that you get a lot of data. You collect some data. Based on this data, you can do a lot of analytics. Ultimately, to do this analytics, you want some data which no sensors provides you, and these analytics will give more intelligence to your system, because you analyze and you come to a conclusion. You will be able to program, or you can make your systems and robots to make some decisions based on the computations we do basically. Getting it? In this case, I'll just break it here to show you people. I'll come here. I'm gonna quickly show you this promotional video. This is a promotional video where there is a company called Kuka. They're trying to show the performance of the robot which they have designed. Okay, just watch this, because based on this, I'm going to show you some more things. This is the slogan. This is the famous part. Actually, this is a promotional video. It is just because this entire video is made only for this. Not the best in table tennis, probably, but probably the best in robotics. Okay, so this is this video where this is a promotional video, as I told you. I'll quickly show you then about how it is being made and how it is being programmed. It is actually programmed using LabVIEW, prototyped in SolidWorks. Nowadays, actually, this was done very long back. It is not a very new application or something. It was done long back, like in the year of 2008 or six. I'm not sure. It's a very old product. But if you see here, this was prototyped in SolidWorks. Okay, nowadays you can prototype this in LabVIEW also. We have some toolkits to do with something called as virtual prototyping. Uh, but it was programmed using LabVIEW. Okay, it was programmed using LabVIEW. Just watch this video. You can see this is a LabVIEW screen where you can set the joints value so to test how the movements are. Yeah, it was programmed using LabVIEW only, but it was prototyped before. It was very long back where it was prototyped using SolidWorks. I'll show one more video. This is where I wanted to show you how BMW car use these robots. This is a manufacturing sector of BMW. I showed you a picture, right? That picture was actually taken from the same. You can see these robots are KUKA robot. Can you see the name here? KUKA. This was designed by KUKA robot. Whatever the demonstration they showed, right? The promotional video demonstration, the same robot. This is to show you that these are the Industrial Revolution 3.0 following robotic applications where manufacturing was happening. It uses arc welding. Okay. This was the actual purpose of this robot. Okay, this was the actual purpose of this robot. Now these robots, we are trying to do it into a fully automation. Okay, so I'll just show one more case study to you people where these same type of robots um, in Airbus, a company called Airbus, basically they have done it. Um, I'll just show you that. Just give me a minute. I'm just seeing which video. Okay, this is different. I have a report for that. I'll just show that report.
We've just seen a great example of how our customers add their domain expertise on top of our platform to create complicated test systems. But there are also times that you may want to take advantage of the deep expertise of one of our alliance partners to ensure your success. To tell us more about how they're helping their customers make the smart factory a reality, please welcome to the stage from NI Alliance Partner GSystems, Dave Baker and James Duvall. Hey guys. Yep. Dave, James, good to see you all this morning. Thanks for joining us. All right, Dave, let's start with you. Tell us about GSystems.
Thanks, Chad. Well, GSystems is a NI Alliance partner, as you heard. We've been for over 25 years providing solutions built on the NI product platform. We design and build test systems, anything ranging from a small embedded system all the way up to a high channel count ATE. And we're excited to be here today to talk to you about the demand for factory test solutions.
All right, we're glad to have you as well. And it looks like you brought a demonstration with y'all.
Right, so this is an example of a system that we're putting together for customers who increasingly are using robotics and automation and data-driven decision-making in their manufacturing process. Now, many of these customers have multiple lines that they're trying to manage. They're scattered across many sites, so collecting data, the status of those test systems can be very challenging. What they really need is a smart test solution that supports their smart factory.
All right, that sounds good. So James, can you help us understand some of the challenges that an operator may face in a production environment that you're trying to help address?
Yes, in fact, I think we have a video that should shed some light on this. So suppose you're an operator and you are monitoring a test system on a production assembly line. Now, what happens when something goes a little bit wrong? What happens when something goes a lot bit wrong? Slows everything down, and you can't actually leave your station while things are underway. And never underestimate the creativity of an operator who is trying to keep the line rolling.
All right, well, whether or not you're familiar with the classic show I Love Lucy, Lucy's environment isn't exactly a high-tech production environment, but her humor helps us relate to the challenges an operator may face when things start going wrong on the line and they begin to fall behind.
Right, so production lines are having to increasingly increase their output, reduce their downtime of their test systems, and rely on data. And to be able to be successful, that needs to be timely and up to date. So what we're doing is putting together smart solutions that enable them to have a network-based dashboard view of their production line status, and also some capability of managing those test systems.
All right, so help us get a sense for how NI is helping you make that a reality.
Sure. For this system, we've standardized on Compact Rio, LabVIEW, and SystemLink. We've developed a LabVIEW real-time application to capture and process measurements. We're also using SystemLink for remote management and system monitoring. And GSystems has designed and assembled a custom enclosure for the C-Rio, complete with this high-visibility stoplight indicator, so we can see the status of the test. We got one running here and another one in the expo hall at our booth.
All right, so you're taking advantage of LabVIEW and Compact Rio as well as SystemLink. And SystemLink is a great example of our increased platform investment to make it easier for you to manage remote and distributed systems. Let's take a look at what it has to offer.
All right, catchy music. As we saw in the video, SystemLink works with your existing LabVIEW environment. It also comes with a central web application for remote management and system monitoring. I'm going to show you a little bit about how it works. So this is our little test station here. We've got a little test article here. And when I push the button, this is a good one. So we should pass. Oh, good. we get 3 red lights in a row, that's going to cause an alarm.
Oh wait, that's me. I'm over here blowing up this morning. Yep, sure enough, System Link just sent me a text message saying that we have a problem, which is pretty cool. Haven't we been able to do something like this with LabVIEW for a while?
That's right, Chad, but here with System Link, we're able to configure new alarms without having to do any additional programming. In this case, System Link was configured to throw a new alarm whenever we had 3 failures in a row. This would prompt us to get on the System Link dashboards, which will give us a quick view of the status of the line.
All right, so we're making it easier to take advantage of capabilities like this, but my real question is if System Link can help us bring the station back online from a remote location.
Absolutely. Normally, we would have to basically dispatch a technician out to look for problems in the workflow. In this case, however, we've got a new UT, and we can use System Link's remote deployment feature to put a new version of the software out to go ahead and fix the tester up. So I'm going to run this again with some new software on it. There's a green light.
All right, so once the system's been updated, the software can verify the functionality that the test station is back online. This rapid notification of production line status and the ability to remotely configure it is really critical for meeting our daily production targets in a production environment.
All right, so we're essentially catching and correcting small issues before they become major catastrophes, which I know is a goal of many of you in the audience today. It's also great to see how you can take advantage of the domain expertise of NI Alliance partners like GSystems to ensure your success.
Right, Chad. So NI's product platform is crucial for GSystems success as well as the success of our customers. We're striving to not only meet today's requirements, but to prepare our customers for the future for these additional challenges of increasing their production rate, reducing their test station downtime, and doing some decision-making support.
Oh, that's me again. Let's check, see what it tells us. System Link has given us a notification that it's time to wrap up so that we don't fall behind on our keynote. Thanks for joining us this morning.
Thank you very much.
Good luck with your factory applications.
Okay, this was a demonstration where they were trying to demonstrate in a production line if the operator experienced some downtime or any failures on the machine level, what can be done. Basically this is what is called as basically a health monitoring, where what happens is the information will be always gathered, and there is a continuous 3 fail from a machine, which means that there is some problem with the machine, maybe not with the DUTs which is being tested, and the information is carried through a system link, where what happens is the system link carries the data powered by LabVIEW, basically takes to the main center, and all the information also goes through in a phone to the programmer or to the base station helper who can eradicate this problem. And from there, base station, you can take the control over the machine and try to sort the issues. Okay, this is where there are different, as I told you, there are different ways people are trying to make this entire production system smarter. Okay, so everyone coming up with one different methodology, where they can understand how to make the smart factories even a better efficient place to work, right? So ultimately what they're trying to do is they have come up with different solutions where they can try to eradicate the downtime, especially the unplanned downtime. They want to eradicate. How to do it, they were trying to do how to accelerate the production in case there is any emergency production happening. If the downtime happens in those days, how to handle it. They're trying to showing a demonstration. This was a pretty old video where they are trying to simply not making the machine to take the decision, where the control was switched to a different place, remote place, need not be in the same place, to a different place, and from there, yes, they were trying to control it and make a better solution or a better upgrade on the software so that it can be immediately being put into the production. Okay, this one smart system they were trying to design. There is one more or the better way of doing, I'm going to show you, where NI has spent a lot of effort in building that. So what I'll do is I'll quickly take you through this. I'll come back to this IoT again because I want to show you something else which is slightly more interesting for you people. Yeah. So I'm just trying to bring you people to something called as TSN. Okay, time sensitive network. Okay, this is nothing but usually since currently I have not come up with a proper solution about network usage. we are still using the same www, where we are transferring all the data and information through the same protocol what we people used to communicate. Now, that is where we have to make it more careful about how we use the systems. Okay, now just imagine a network. Okay, imagine a network where we are trying to uh, normally use for normal R application. Let me say I'm downloading a software, I'm trying to install something, I'm trying to play some YouTube video. It is streaming video. I want to see these things. Parallelly, there is a production sector which is running on my same floor. We are sharing the same network. Let me say, in those cases, I'm trying to talk to you all about that case scenario, case study, how to handle it. There is an important control unit, like how I demonstrated now, the G system, where there is an important production happening. If there is a downtime, this information has to be taken to the main remote base station. From there, a control action has to be taken. That is a very critical application, because maybe the error or downtime might even hurt the machine. Okay, the machine is going to be broken if we are continuously running along with it. Right now, the problem is both are happening the same thing, because I'm watching a YouTube video. Let me say that is not that important compared to that particular emergency call which we are getting from the mission on the production. Right, so now I'm supposed to understand which is the more important application to be transferred, because there is a huge amount of traffic. I'm just talking about a simple example. Think about a huge number of missions involved. Right, in one production sector there can be hundreds and hundreds of missions. The number of people employed there are also more. Number of devices connected is even more. Okay, in these cases, after telling this, I'll come to one more reality truth I want to tell you. I'll tell you that about that. Okay, that's where they came to something called time sensitive network. Time sensitive network is nothing but it tries to manage the multiple communications. If there are multiple communication, okay, it tries to understand the priority of which kind of transmission is a very prioritized one, and which is non-prioritized one, and try to stream them according to the priority. Okay, and both will happen. It will not stop any of them. That's a very important part, because it happens that you can say that that is the most prioritized one, this is not much prioritized, so I'll stop this streaming and I'll allow that to happen. That is basically trafficking. Okay, this is not only trafficking, it is also synchronizing. It can do trafficking also. It can also try to handle the traffics, but also it can do the synchronization. Okay, a smart synchronization. This is one of a very best solution what NI has come up. This is from NI. This TSN technology itself only from NI, and they are trying to show you what are the different types of technology they came up. There are common technologies available. Whatever they are trying to show you in the screen right now is basically the technology what they have initiated. TSN is one which they designed it along with Intel and Cisco, tying up with Intel, National Instrument, and Cisco. They have designed this. I'm going to quickly tell you how this works. See, first of all, for this, you should understand what is a IT and what is a OT. Very quickly, I'll tell you. So, IT is nothing but is an information technology, and OT is nothing but an operational technology. When IoT comes into picture, as I told you, in the Industrial Revolution 4.0, we already have a physical system. These physical systems are going to convert into a cyber physical system. Okay, so when cyber and physical system are going to come into picture together, there's something called IT. IT is nothing but the cyber related data are called as IT. The digital informations, the data which you transfer, the protocols what we use, all this information will be called as IT. Okay, related to cyber informations. Okay, then comes OT. OT is nothing but operational information, where the physical data about this the program which is running, how much memory it is using, how much time it is running, what is the shift it is going on, all related to the machine information will be called as OT. Okay, when these two comes together, that is where TSN is usually needed, because normally you also have to control the machine. You should also stream the data, right? You should also stream the data. That's where TSN comes into picture. So when TSN when is a TSN needed is when IT and OT converges. So OT is nothing but here on the left side. Just look here. When I talk about OT, operational technology, machineries, equipments and assets, monitoring systems, control systems, all machinery items. Coming to IT, storage systems, where the data has to be stored, the informations have to be stored, computing technology, business application, data analytics, which are all related to software and networks. Then they converge. These are the common levels of common levels of applications you usually come up. Okay, these three levels L0, L1, L2 are smart connected assets, like IoTs, enabled sensors, instruments, controls, assets, and materials. Low level of items. The next level can be smart connected operations, like IoT enabled production, quality, inventory, and maintenance. And the next level can be business systems, IoT enabled business systems. And the last, the topmost layer can be IoT enabled government and planning system. These are the items or levels of applications you can develop by converging IT and OT. That is nothing but while converging IT and OT, these are the byproduct applications you can design, levels of applications you can design using a smart factory or a cyber physical system. This is where we come across there are different levels of applications: simple level, moderate level, and then high level and very high priority levels we have. So when you have different levels, now you are supposed to decide which has more priority and which has more trafficking. All this information has to be shared. That is where TSN comes into picture. I have the video for this. I'll just quickly play how TSN basically works. There was a very nice demonstration. Yeah, this one. This is TSN. Yeah. There is a lot of talking here. I'll just quickly move to the demonstration part. They'll be telling the same thing which I told you. So I'm just skipping some of the items. I'll go somewhere here where okay, probably here.
And cross industry boundaries that have been historically set.
They'll start a demo now. Just watch.
To deliver on the promise of the industrial Internet of Things, we've been working with technology leaders Intel and Cisco Systems. To learn more about how we're building the network of tomorrow, I would like to invite to the stage Kevin Stanton from Intel, Paul Didier from Cisco Systems, and our very own Todd Walter. Welcome, guys. Welcome, Paul. Hey, Todd.
Thanks, Jamie.
So the three of you guys met in the very glamorous world of standards body work.
Yeah, Kevin, Paul, and I met while working in a variety of organizations working to define, standardize, and drive adoption of some new technologies for Ethernet. That includes the IEEE, a group called Avenue, and the Industrial Internet Consortium. Jamie, you just mentioned the need for data access in these systems, and that's really what we've been working in, is adding that into these networks, and we call that convergence.
We still predominantly see non-converged networks. We see IT networks connecting people to data at home and at work. And we see operational OT networks controlling machines, connecting plants and grids to each other. The cables and connectors in these networks might look the same, but the objectives and the underlying technologies are quite different. To deliver the promise of the industrial IoT, we need to converge OT systems and the IT infrastructure.
Yeah, and to show that, we built a simple system on stage. So what we have are 4 compact Rios, 2 that you see here in the middle, and 2 that are distributed to far ends of the stage. These are all connected through a network of Ethernet. And what we're going to do is control from one compact Rio, this motor disk. We'll send those commands over the network to the other 3 disks, and they'll try to follow it. So let me go ahead and start this demo.
Great. All right, looks like the disks are spinning now on all 4 of these systems. So you have one compact Rio that's sharing position data to the other 3. Everything looks synchronized and coordinated, and you're using a standard IT network, Todd. So what's the problem here?
Yeah, well, right now there is no problem, but what comes in is this issue of convergence. So when we want to put this and mix it with our standard IT infrastructure, we're going to have other data flows, not just our green flow right now. So let me do what would be very common in an IT network. We'll add some additional traffic. In this case, I'm going to stream some video from this computer to that computer through this same link.
Yeah, we can see that the video traffic is actually causing problems for the control system. Maybe we better shut that off, Todd. What's happening is that the video traffic is causing some of the control frames to be delayed past their deadline, and actually some of the frames are being dropped entirely.
Yeah, now if this had been a machine, a real working machine, this would have caused potentially damage to the machine and certainly would have damaged the parts that it was making.
So historically, this is why OT and IT networks have been kept separate.
Yeah, exactly. And we've been working on a way to converge it. So let me show you that technology as well. I'm going to clear these faults and I'm going to switch modes now. Now I'm running in a TSN mode where these blue traffic are using these new capabilities. And now when I add the streaming traffic,
all right, so what we see here now is we have the video data being streamed across the network right alongside our controls traffic. The controls traffic is going through undisturbed from one compact Rio to the other three, and we're saturating the remaining network with this video data. And it looks like it's working great. Paul, how does all this work?
The foundation of this converged network technology is time-sensitive networks, or TSN, an evolution of Ethernet standards that are created by the IEEE 802 Standards Committee. NI, Intel, Cisco, and others have been collaborating to enhance Ethernet with deterministic operations that are required by the OT system.
That's right. The team has been really enhancing networking so that the time performance is improved dramatically. And we're doing this by adding three main capabilities. The first of which is precise time synchronization, and that's accomplished through a standard called IEEE 802.1 AS, and it's based on 1588, the precision time protocol that's been around for about 10 years.
Next, we combine time synchronization with traffic management to deliver latency guarantees. Each switch identifies the time-critical data and places it in a special queue. The switch then forwards each of these packets at very specific times. Okay? What this does is create a network flow or a virtual wire between the talkers and the listeners across the entire network.
and the third element for this is system configuration. We're taking a page out of software-defined networking to abstract the network configuration from the end application configuration.
All right, so most of our customers at National Instruments are not IT professionals. So, Paul, how are they going to leverage this new technology?
Easy. Okay. LabVIEW requests reservations of the network by specifying which data is time critical, which nodes need to receive that data, and how long it needs to take to get there. And then in SDN fashion, software-defined network management will evaluate the network, will create the schedules and the routes, distribute that to the network infrastructure, and then provide LabVIEW with network and timing parameters.
Yeah, working with Cisco has clearly been essential in bringing this forward, and it's been a great working relationship. Now, what might not be quite as obvious to the audience is the great collaboration we've had with Intel in bringing this technology forward.
Yeah, at Intel, we're very excited about TSN and what it means for bringing IT and OT networks together onto the same network. We're shipping a Ethernet controller that supports these standards. We're taking some steps toward making sure the value of TSN between systems is also available to applications on the endpoint. And we've released a open source project for these standards and technologies, and I'm happy to note that NI has been a key contributor to that open source project.
And Kevin, yeah, we've been thrilled to work with you on that open source software project. So we know we have the Intel i210 network controllers inside the compact Rios. We've been working very hard with Cisco on software integration between their software and LabVIEW. So Todd, how can our customers get their hands on this technology?
You know, our customers are especially well poised to be able to take advantage. Some of what you saw from Jeff talking this morning because they're already using LabVIEW. And LabVIEW for years has had constructs that base their execution on time, whether it's the time loop in LabVIEW real time or the single cycle time loop in LabVIEW FPGA. So we're happy that we're able to bring these out to market. Later this year, we will be introducing an early access technology release That'll consist of these new compact RIOs with TSN capabilities that can be programmed in LabVIEW 2016, along with these Cisco IE 4000 switches and the necessary software for configuration.
That's great. Wonderful. Well, Kevin, Paul, it's been great working with you on this project.
So what was the demonstration here? I'll just quickly try to recap it. They had, a proper data transmitted in a normal mode, and also there is a second network on this. Same network. There was a second streaming of video. So when both were happening together, the IT and OT, when they converge together, what happens is you'll come across the data loss, data trafficking, all these things will come into picture. That is where TSN was demonstrated. They showed you, they were telling you, explaining you how TSN was working, how Intel, LabVIEW, or NI technology, and along with Cisco, how they were trying to make it happen, how they were trying to demonstrate. With that, you'll see that both gets transmitted, and not only two. Basically, the idea of TSN is not only two networks or two transmission in one network. It can have n number of transmission in a single network without data trafficking. Okay, that's a very important part. Ultimately, the idea is they try to convert the data into bit, and they try to send the data in bit and collect it there and try to assemble them all back together. So what happens is all data are merged together. They're smudged together, not even merged. They are smudged together, and they'll be reverting it back. So this was one of a interesting technology where they wanted to make it more smart. So depending upon understanding, which is more prioritized, which has to be stopped, it can also do trafficking as said. Okay, if you want to, depending upon the priority, if you can set the priority there in the TSN, you can also understand that this particular transmission is not needed, and it will totally stop it, and other systems will be properly trafficked. Okay, so properly synchronized. So that is also possible. This is one more way of making a smart system. This TSN, before it was coming it as a external model where you have to write a program and you have to make it synchronized. Now this is now included into the NI hardware directly. So now you can just buy NI product saying that I want a CDAC with TSN enabled. You can also say I can have a CDAC without TSN. So they have come across in such a way that you can specify you want TSN in that as a feature. So it is inbuilt. So it is inbuilt. You don't have to program it. You can just switch on TSN mode. Okay, set the priority, and when you configure it, it will ask you all the required details. Okay, so you can set the priority, and once you set the priority of the TSN, based on that priority, any communication or network streaming will happen properly. All right, this is how this application basically works. And so ultimately what TSN brings to you is TSN basically gives you time synchronization. They are showing you, and protocol they use is 802.1, and then it reduces the latency. It is bounded to low latency. Okay, so then it also have a ultra reliability. It's nothing but you will not have any data transmission loss. It's a very simple how it happens is it try to replicate the frames. I told you there are nothing but bits of data. I told you, okay, all are converted into bits of data. So those bits of data are called as frames. So these frames are replicated in such a way you will not miss any of them, and you will not eliminate any of them. So you will replicate them. So in case if any of the frame is failed or it is not transferred, what happens is the replication will be taking over, and in the other end, if the data are transferred properly, the replications will be eliminated. Okay, so then you have dedicated resource. Dedicated resource is nothing but you have Intel IC. Basically Intel is what providing these ICs for TSN for NI technology. So this Intel IC, what they do is they take care of this processing of finding trafficking or this algorithm, whatever is needed. Based on that, a resource is being allocated for that, and it will take care of all the process. They are using stream reservation protocol for this. Usually we have the different protocols for this. They use stream reservation protocol for this. Okay, and because of this you'll have zero congestion loss. Congestion losses when you're trying to transmit multiple items together. All right, when you're trying to transfer multiple items together, because of the trafficking, the congestion, because of many things are trafficking or crowding up the network. Based on that, if you are losing anything, that is basically called as congestion loss. This TSN will make sure zero congestion loss will happen, even though we people use the same network for IT and OT. IT is nothing but information technology, where the data, actual data are transferred. OT is nothing but your computer related data, monitoring data, my usual information, like I'm streaming a data, I'm just watching a video or whatsoever. They are basically called as a OT data. Getting it? Yes. So this is what basically TSN will help you to do. And if this is clear about how TSN works, there is one more method. This is one method where NI. Before I showed you is a G system. How G system is trying to do a smart system, a smart factory system. Okay. Now what I showed you was the TSN system, which NI enabled it. That is also once again a smart system which allows you, better transmission on a same network. That is very important, because of this problem, you see most of the industries or most of the colleges, you'll see when there is a very high priority data are transferred in one of the network. If you don't want that network to go low, they use a separate network for that. Okay, now this was a demonstration shown to you where you don't have to use a separate network. Only thing you have to do is you have to use a technology called as TSN technology. That was this demo. Okay, following this, I'm going to quickly show you one more smart system design. This is more similar to the KUKA robot which I showed you, right? The KUKA robot I showed you was without AI system. That is basically without AI system, which was Industrial Revolution 3.0's product, where you will see that it is being used for all the manufacturing, in the manufacturing sector. Okay, so this one which I'm going to show is a Airbus. The company name is Airbus. They are once again using NA technology to do a smart system, smart factory system. I'm going to quickly show you how it works. This is a very interesting video to my perspective, because it is more like how you see in movies. There'll be the Hollywood movies, whatever they show you, right? This is more similar to that. Just pay more attention. I love this video so much compared to any other video which was shown, because this is visibly the best solution, or the best the guidance what the system can give to make the entire industry smart. Just watch this. One problem is I think the sound will be slightly less. The sound quality is pretty low, but audible.
visualize the QR code you see on the production. And also, on top of that, the actual distinguishing features on the pole and the general path. From that information, you can identify what path the engineers look to complete. This was done by using their existing algorithms that Airbus already have, and also their OpenCV algorithms from another company. Well, on the production floor today, you'd be using 1 over 1,000 different tools in order to get the job done. But now, because of this tightening split between wearable intelligence devices and smart custom tools, technicians simply have to place the tool in the correct location, and the system will identify what particular job it is that they're looking to complete, apply the correct amount of torque, and not only that, it will log the entire process to a quality assurance database. Well, at this point, most of the audience will be wondering how Airbus protects that since pretty clearly are not wearing a contact reader. Well, the team over here would have been wearing one because they began their development of the contact reader. But when Airbus came to NI and told us about their plans for wearable intelligence, we agreed that their application was a good fit for the new NI system on module. Now, the system on module is the smallest ever implementation of the LabVIEW Rio architecture. As you can see here, it's the same size as a credit card, which makes it ideal for low physical footprint applications and high volume deployment. The LabVIEW Rio architecture has a key advantage, which is that no matter what form factor you're on, you can use the same software and the same IP, which is exactly what Airbus has done to minimize their change over time to the soft platform. Yeah, sure. So, as I said, we neither have the plane nor the tools for today. But what we can do is take the video that we saw before, feed that directly into the slot, where it will carry out the onboard image processing. And then rather than sending commands to the tool, which would be dangerous, we have to send those commands to a small interface over here. So, Rick, if you would have a look at this display here, we'll get a demonstration for it. Now, Joel, obviously, I'm very interested about this. Yeah, of course. So, Airbus have a plan called the Open Robot Interface. Now, in their manufacturing operations, they utilize robots from companies like ABB, KUKA, and others. They want to be able to integrate these robots with their new smart coding technology. In order to do this, they'll have to scale their robotics application software across all their systems. Operationally, they're going to do this by using the contact Rio to supplement their existing industrial controls. In addition to this, they're leveraging code from the Linux community, software and robot developers themselves, and their other factory of the future designs. The factory of the future is a huge ambitious vision that the team is now making rapid progress. Ever since they adopted a platform-based approach using the LabVIEW Rio architecture, the team is simply more productive. Compared to the other approaches that they tried, there's been a 10x reduction in development time. It's so exciting to hear about the progress that they're obviously very much achieved. Anytime that is well, obviously, this is what I was talking about. So, next gen systems are always quite difficult. Incredible application, but in as positions engineers, each of which is how much my graphics let there be no doubt there is a wide development of a wide platform to ensure a bright future of innovation and discovery. So I think with that time again, I hope you guys will define and confident. Please enjoy the rest of your NI days. Thanks.
So I'll quickly tell you what was the thing. Usually, the robots are basically doing all this, manufacturing and other things. All right. So now let me say there is some fault which is basically has to be manually handled. Okay. So there is a failure. Let me say there is a failure or emergency situation whatsoever it is. So the ground person may not be knowing what is the change or where it's supposed to happen, right? So what this happens is this they can wear this glasses. This is a smart glass basically designed by National Instrument for Airbus, because this is only for Airbus, because all the details related to the Airbus company's flight informations are loaded into this glasses. So what this happens is once you put on, and once you can see that, it will let you know about what are the different types of problems being uh, you see through the glass. So the glass itself will act like a display. So what it says is, it says that basically you are trying to fix this accelerometer in a different axis. The axis is wrong, the screw is not tightened, or whatever maybe the problem is, it will let out the problems and will try to list it out on the glass itself. So a person with without much idea, if he's trying to walk around wearing the glasses inside that the Airbus where there's a fault, like inspection system, what happens is the glass, when you see there the image, on the image whatever you see on the glass, it will just replicate what is the problem, and will try to tell you this is the problem you have and you are supposed to actually eradicate it. This is one of a very interesting application. That smart glass is a very important application whatever they have designed. All right. So apart from that, there's multiple feature which they are trying to demonstrate. Clear? Yes. So these are some of the demonstrations or the case studies which I'm trying to show you. Any queries, anyone? I want to come back to the query session. There might be some queries. I'll just try to handle them. Is there any query, anyone? Do you want to post any query, or if you want to ask me any queries? Anyone? Any queries? Okay, thank you. So if there is no much queries, I'm going to quickly jump into the AI system, what NI allows you to work. I'm just going to quickly show you about the AI system. Basically with LabVIEW, why am I trying to show you the AI system before? I mean, first is to some extent, I think the IoT, how to send to the cloud and other things I'll show to you. But I want to quickly show you this. See, for AI system, you can have a separate installation, which is called, I'm just opening LabVIEW screen. Whatever you see here now is a LabVIEW screen. I've just launched the LabVIEW screen front panel and block diagram. So here, once you do the installation for, or what to say, your machine learning or deep learning, you will find that data is related to that. Okay, so I'll expand this. I have an add-on. Inside the add-on, you can see biomedical toolkit I have installed. Apart from that, I also have machine learning. I have not installed deep learning, so deep learning is not available here. So machine learning, when I go inside, you have supervised technique, unsupervised technique. There are different types of techniques you can use. Okay, I have made a simple example, not a tough one, a very simple example of KNN. KNN stands for K nearest neighbor. The K is basically the factor how many nearest neighbor you are supposed to consider to take a decision making algorithm. Okay, this is a decision making, or I can say it's a prediction. I can't even say it's a decision making. It's a prediction analysis. Okay, KNN, based on the K number of, K is nothing but the number of neighbors you want to refer to come to a prediction, conclusive prediction. Okay, so you can use this if it is image processing related application, because there are a lot of applications related to vision inspection system we have. If it is image processing related machine learning, deep learning algorithms you want, you can go for vision and motion. Can you just right click here, vision and motion? If you're not done any installation, it will be blank here. This palette will be blank to you, but I have done all the installation related to, not all, basically speaking. You can see there are some empty gray spaces. So there are the toolkits or the libraries which is missing. For basic thing, whatever I need, I've just installed it. You can see here there's something called machine learning. Okay, on the 5th row, for my 3rd row is empty, completely empty. The 3rd row is completely empty. 1st row, 2nd row, 3rd row, 4th row, 5th row, first one, you can see machine learning. Inside that you have deep learning training also. Okay, how to set the input model and all other things will be there. So for machine learning, you have some classification techniques, how you can do the classification technique. All right. So I have a simple example which I've made it. I'll quickly tell you what is that example basically doing. First, I'll open this uh, Excel sheet. So what is this Excel sheet is nothing but it has some preloaded set of data. Okay, preloaded set of data. These are the datas or these are the neighbors which I'm going to use for the prediction now. Okay, so neighbors are nothing but usually these information usually will get plotted on a graph. Okay, they'll get the data will be scattered in the graph, and if you're predicting some value, it will check the nearest value which you have feeded here. So you can see here. So you can see here. So for my heart pulse measurement, so for this value there is two conditions. One is abnormal and normal. One is abnormal, zero is normal. Okay, so anything around the range of 70, okay, from 70 to 79, around that range, or even 82, sorry, around 70, anything around 70s will be considered as normal. Lower version 60, 65, 66, 63 will be considered as abnormal. Beyond 70 plus, okay, sorry, beyond 79 plus, okay, beyond 79 plus will once again will be considered as abnormal. Okay, so this is the values. There is not all values are present here. Few values are present here, and the condition is nothing but normal, abnormal. There are two conditions I have. You can have multiple conditions also. You can have a number of conditions. Okay, I've just trained it, only for this. This is a data set. Basically, this is what is called as a data set. Usually, the more the data set, the more accurate data you can obtain. Okay, the more the data set, the more accurate data you can obtain. I'm going for very less amount of data, which is like only 20 data I have. I'm going to use these data to perform the k nearest neighbor. Okay, in LabVIEW, I told you, right? Right click, add on, machine learning. So here you will see that in supervised technique you have k nearest neighbor. Okay, you have k nearest neighbor. KNN is k nearest neighbor. I've done the code already. I'll just open this. Okay, so here what I've done is, can you see here? This is nothing but KNN, which is nothing but the same replication of this. Whatever is here in KNN application, I'll show the block diagram. So whatever is being done there, the same thing is replicated. So here I've just loaded that particular CSV file. That is the Excel sheet I've loaded here. The data are obtained here. From there, I'm extracting the data and performing the KNN. The K value, I've just left it to be 3. Okay. So 3 is nothing but, so how many neighbors you have to consider to come to a conclusion. Okay. How many neighbors you have to consult to conclude, to come to a prediction. Okay, to come to a prediction that's saying that this particular data which you set, you specify the sample, new sample data. Let me say, based on the data, whatever is being mentioned here, if I say 100, it should say it's normal or abnormal. It has to predict the value is normal or abnormal with the already pre-existing information. Clear? Okay, so what happens is this k value usually should be always try to have it as a positive number. Okay, number one, it has to be a positive number. Number two, it has to be an odd number. The reason why odd number is, see, you have two classification values. Okay, normal and abnormal, two classification values you have. So here, if you go for an even number, there is all chances that, let me say the even number was 6, k value was 6. If you take k equal to 6, 3 neighbors might be, class number 1, 3 neighbors can be class number 2. So in those cases, to make it more, reliable data, what you have to do is make sure the value is a odd number. All right, the value is a odd number, and always, if the number of, the cases are 2, go for a k value higher than the number of cases, which means there are 2 cases here. Okay, there are 2 cases here. Go for 3 or 5 or 7, something like that. K value. Getting it? Okay. These are the common criteria you have to follow to make this, thing work. So now what I'm going to say is, I'm going to say the new sample value. I don't know. I'll randomly give somewhere around 76. It can be a fraction number also. 76 I'll give. For example, I can give even fraction number, for example. Okay. So here, this has to be predicted. The output should be predicted here. The predicted label should be 0 or 1. Label is 0 or 1, nothing but there I wrote it as 0 or 1, right? In the Excel sheet, that is a label. Okay. And the status is here. Normal or abnormal will come here. Okay. So when I run this program, see, you can see that the Excel information is read here. Okay. The external data, it can be a normal Excel sheet or a document or a, it can be text sheet. It can be anything. From here, I write it. Okay. So that will be read here. All those data will be read here. And here it is predicted to be normal. 76, because based on the nearest values, the nearest value somewhere like 76.8 is the nearest value. 76 is the nearest value. These are the two nearest value you have. One more nearest value will be somewhere around 72 maybe. Okay. So now I'll go for some value like, 76 maybe. Okay. 76 is already existing. I'll go for 65. Okay. I think 65 is not here. When I run this, to the nearest value of 65 in this level, in this, the sheet, okay, it is clearly mentioned that, it is a abnormal data. I'll just go for some higher values, like, I'll just say 100. The nearest value will once again predict it to be abnormal. Somewhere this is designed in such a way, somewhere around, 72, I'll say 72 is not there, I believe. So if I say 72, I think 72 is not here. 72.5 is there, but 72 value is not there. So when I run it, you can see it is a normal. Okay. So there can be, high fund application, like, I'll quickly show you some of the applications like classification. Classification is also more similar to this, because there I'm classifying whether it is, normal or abnormal. This is more similar to that. This is classifying into multiple labels. Okay. In real-time video. Just watch. Object detection. Right? So that was a simple example. Once again, prediction wise, there is one more video based on deep learning. Whatever I showed you now was the machine learning. Whatever I showed you, the video which I showed you was a machine learning, simple machine learning. This is a deep learning. This is all based on LabVIEW only. Whatever I'm showing you is based on LabVIEW program only. This is an application which is designed using LabVIEW. So when a handwritten data is there, it is trying to read it and try to come to conclusive data, saying that it has to be value of 5 or 6. You can see the score coming here. Getting it? So whatever a person writes, you can see here, whatever a person writes, that particular data will be predicted. Getting it? So these are the techniques, different types of techniques that are being used for, making your application to be more smart. Okay, internally. There are different methods I'm trying to show you. Okay, TSN is one method, because most of the time when I say AI, people only think about, a robot which can make decision. Okay, that is not only smart. That is a basic thing I wanted to make a conclusive statement here to you people. A smart system can be of anything. A TSN is a smart system where there is no much of, decision making algorithm. Okay, there is just a synchronizing algorithm making it more smarter. Getting it? Compared to a regular application. Yes. And prediction, or your classification, these are also one type of decision making algorithms, making your system more smarter. Any queries, anyone? Any queries? So if you have any queries, you can just post it here. I think we are really running out of time. I just wanted to show one more demonstration of how to push the data into the cloud and retrieve it back. Maybe we may not have much time on that, but I think you have already seen it, how to push the data into the cloud, right? How to design a Firebase cloud and how to push the data into the cloud. It was demonstrated a couple of days before. This is going to be the same thing. I wanted to simulate it and I want to retrieve it back. The two things which you have to understand when it comes to IoT. Basically, when it comes to IoT, there is something called as active cloud and a passive cloud. Okay, there's something called as an active cloud and a passive cloud. Active cloud is something where it allows you to do the cloud computing in the cloud itself, which means that from lab you are pushing the data to the cloud and it is stored there. From the stored cloud, you're retrieving the data back to the LabVIEW, and all the processing, all the analysis, all the analogy happens on lab only. Okay, the platform only. I mean the automation platform only. But if you want to do the computation in the cloud level, okay, then you have to go for an active cloud. If the cloud doesn't allow you to do it in the cloud level, then it is called as a passive cloud. It's not an active cloud. It can only hold the data for some time. Okay, it can only hold the data for some time. It cannot actively do all the computation. So cloud computing will come into picture when you can do the analytics there in the cloud. Okay, there are n number of softwares or platforms like IBM, Firebase also. You can pay much more features and you can take the active cloud. By default, whatever they give you, Google gives you the passive cloud only. But you can, it has a facility to do the active cloud in processing, computings and other things. And there is IBM. There is also from Amazon. You have WBS. You have UBBot. Sorry, DAC-IOs. There are different types of platforms is available from NA technology. I mean, which will serve NA technology. These are all things which I'm telling you is interfaceable with NA technology. Like Google Firebase is one interface for LabVIEW. Okay, interface that can be done through LabVIEW. That's what I have to say, because you can use Arduino, you can use C program, you can use Python program to do it. It is possible. It is open source. It is accessible. I'm trying to tell the list of things what in industries they use to access it. Clear? Any queries, anyone related to this, or any research work you people are doing there? Where you want any queries or something? If not, I would like to share my contact details to you people. One more thing. Yeah, I just wanted to say one more thing about this. I totally forgot. Thankfully, my slide helped me to show you. See, NI is National Instrument. Currently, they worked on all domains before. Now they are streamlining into some sectors where there is only where there is a chance of IoT, 5G research, all these IoT based applications and smart systems will be involved. So in that case, if you see semiconductors, automotive, aerospace, defense, and wireless for 5G sector and other things, and wide area network and other things what they're trying to do. Okay, and apart from that, energy management like battery management system, smart grid analysis, microgrid analysis, all these things. It's what NI is basically concentrating on. Okay, so what is that they're trying to invest is, if you see the image processing application, there is not much going to be NI's involvement in image processing related application. They already have some. Okay, they're not going to invest their applications capital cost in development of toolkits or products. They are not going to invest much into that. The reason is they don't see any scope already. Okay, where they see the scope is aerospace, where the flight testing comes into picture. It is always evergreen. Always there is going to be a war when till the earth ends, till the human beings are alive, there will be somewhere people are fighting and there will be some war. Defense is always needed. So NI decided to support that. And then automotive is nothing but now everyone wants automotive car, bike, battery management systems in cars, battery cars, battery two-wheelers. You also people are looking on for everyone are moving towards electric. That's why energy conservation toolkit there. I mean toolkits they have they have phase PMUs. There are a lot of things what NI gives, and semiconductors a common basic thing where everything falls under this, like FPGA. You want RTOS application, right? So all these things will fall under here. So these are things what NI is now concentrating only on for at least for 20 years down the lane. From now to 20 years. Beyond that, they also are investing a lot on academics and research. They're investing a lot on academics and research to just make sure much more further changes. If anything the industry is going through, it will be always monitored using this research. Okay, so to your student or to you people also, in case if you are making a career in NI technology, whatever I was trying to teach, or Mr. Rajkumar was trying to teach on the very first day or a couple of days before, NI basically certify you people to make sure that they have standard people who can do all these things. Okay, so I would suggest you people to concentrate on CLAD. CLAD is a certification what National Instrument gives us a recognition globally by adding your name or whoever is getting the CLAT, their name into their website, so that all the NI users will come to know that there is a certified person who will be able to do our application task. That's like a forum they already maintain, like a group they maintain. So everyone are like communicating there. All right. So there are different certifications available. The first level is CLAT. It's a MCQ type of questions, MCQ question where like there are 40 questions out of 28 right answer to be given. It's 1 hour online exam. All right. It's all based on basic LabVIEW and DAC system. Basic LabVIEW and DAC program, what Mr. Rajkumar showed you. All right. So this will be the best entry point for developers for testing. If you are interested in as a tester, then you can go for this level. Okay. So I would suggest you and your students to prefer this. The simple reason is there are a lot of opportunities coming up. As I told you, this is a new network. I mean, where we are trying to have people around where have some good knowledge and LabVIEW, IoT, artificial intelligence, smart factories, IR 4.0, all these things we are needing. Okay, so we just trying to promote this so that we'll also have some good quality engineers in NI technology in India also. Okay, there are a lot of people who are working on NI technology. You can just go and browse it, other countries. But in India, I don't know how much people are having awareness towards this. So we are trying to bring some awareness, like what are the research work going, what are the job opportunities happening, what are the new companies are coming up. They are working on this. That's the reason on the very first day I was telling about different companies that are using NI technology. I was telling you people about that. All right. So I'm just closing my application right now. So I'll just go for demonstrating my LabVIEW. I think I've just completed with that. So I'm just showing my contact details. If you have any further queries related to NI technology or further any service providing you wanted from us, just let us know. We'll be happy to hear from you. So that I'm just leaving the dais open so that you people can ping me, or you can just unmute and ask me any queries if you have any. All right. Thank you all. Thank you so much. It's a COVID situation. Stay safe, everyone. Try to isolate yourself as much as you can, because ultimately, this is the time we are supposed to be strong enough, right? So just work hard, work as much as you can. Try to spend much time, because this is the time where people have more out of the reach of other people. Even we people are working from home, so we have much time to concentrate on new technologies. So try to use them and try to bring up a lot of research works. If you have any research work you're stuck somewhere, please let us know. So ultimately we are here to help you or find some solution, and let you know that there is a solution possibly through NI technology. If it is available, we are going to help you on that. That is all right. So all the very best to everyone. So I'll leave this dais open to you people. So if you have any queries, I'll just let you people ask me. Thank you all. Thank you so much. The pleasure is mine. Thank you so much. I'm just stopping my sharing, and please let me know if there's any query.
Thank you, Vasant sir. Thank you very much. So very wonderful session. The last day, first session was very much in a high josh like that. So it was nice. So participants, any questions from your side? So I think no questions.
Fine, madam. The pleasure is mine. I'm glad that
Okay.
I was part of you people for at least 2 sessions. So
Thank you, sir.
all the very best to you all,
I
and especially for
have
your
to say
college.
thank you to Mr. Satyanarayana, so who contacted me for this, and he arranged you both, you and Rajkumar sir. So we got a very nice handful sessions. The feedback is also very much excellent feedback we have got because of your sessions. So thank you so much once again.
Sure, ma'am.
Satyanarayana
I'll
sir,
convey
thank
my
you.
regards. I'll convey my
Yeah,
regards to
please,
Satya. Yeah.
please convey. Okay, thank you.
Thank you, madam. Have a nice day, everyone.
We'll keep you in touch for the
Sure,
further communication for us with our college. So that should be beneficial for our students also. So we'll meet again.
Sure.
Okay, sir.
The
Thank
pleasure
you.
is mine, ma'am. Thank you.
Thank you, sir. Thank you. So dear participants, I'll just send the attendance link now, just in a minute. So we'll start the next session at 11:15. That is by mistake it sent. So I'm sending the link now. So this is the attendance link. Please ignore that first message. So the second one is the attendance link. Kindly fill up the attendance link. So we'll meet at 11:15 for the next session. So I request all of you to join for the next session, and thank you.